Let's solve an interesting problem involving repeated differentiation of a trigonometric function. We start with the function y equals 2 sine 3x cosine 2x, which equals sine 5x plus sine x. Our goal is to find a pattern for the nth derivative. Let's start by taking the first derivative. When we differentiate sine 5x, we get 5 cosine 5x. And when we differentiate sine x, we get cosine x. Now, here's a key insight. We can rewrite cosine in terms of sine using the identity. Cosine x equals sine of x plus pi over 2. This gives us 5 sine of 5x plus pi over 2 plus sine of x plus pi over 2. Let's continue with the second derivative. When we differentiate y1, we get negative 5 squared sine 5x minus sine x. Notice how the coefficients are becoming powers of 5. Let's organize what we're seeing. After each derivative, we alternate between sine and cosine. The coefficient of the first term becomes a higher power of 5, and we add pi over 2 to the angle each time. From this pattern, we can deduce the general form for the nth derivative. For any n, y sub n equals 5 to the n power sine of n pi over 2 plus 5x plus sine of n pi over 2 plus x. Let's verify this works by checking it against our earlier derivatives. You can see that when n equals 1, 2, 3, and 4, we get exactly the same expressions we found through direct differentiation. And that completes our proof by mathematical induction. We've shown that this pattern holds for the first few terms and demonstrated how it continues for any value of n.